Humans are incredibly self-confident, and this trait is especially pronounced in uneducated and ignorant people. However, the more information we absorb about the world around us, the faster our belief in our own greatness and power diminishes. Let's consider the differences in scale and the structure of the universe. In a single universe, alongside us live microscopic bacterial colonies and enormous galaxies, the existence of both of which is not fully understood by humanity today. We'll turn our attention to titanic stellar clusters, one of which, though not the largest, contains Earth right now. The Milky Way. Our home galaxy is approximately 100,000 light-years in diameter and about 1,000 light-years thick. These figures are impressive at first glance, but only if we don't try to compare them to the parameters of other stellar clusters. Furthermore, recent research suggests that humans need to adjust to the new dimensions of the Milky Way. Initially, scientists estimated its diameter at 200,000 light-years in 2020. An international group of astrophysicists from Germany, the UK, Canada, and the USA stunned the astronomical community with even larger figures. These modern calculations were based on measurements of the speed of stars inhabiting the outskirts of the galactic disk. It turned out that the stars of the Milky Way in this region are moving much faster than expected. There is a boundary beyond which the dynamic parameters decrease significantly, marking the edge of the cluster. According to the latest data, this boundary in the Milky Way is at the 1.9 million light-year mark, which is likely the galaxy's actual diameter. But this video isn't about the Milky Way. At the beginning, we mentioned the difference in scales. Feel their full extent. Meet IC1101, the largest galaxy in the universe as of today. Naturally, in the future, comparisons of sizes will be unavoidable, so the Milky Way will appear repeatedly in this video. To understand the true scale of stars, vivid examples are often given. What if the Milky Way were replaced by IC1101? It would engulf not only our galaxy, but also Andromeda, the Magellanic Clouds, and Triangulum. In short, practically the entire local group, which in turn is part of the Virgo supercluster. IC1101's diameter is 6 million light-years, an incredibly large number, even considering the newly discovered data. IC1101, a cyclopean cluster, is located more than 1 billion light-years from Earth and contains about 100 trillion stars. Our galaxy can't boast such a stellar population. Its spiral arms contain only 200 to 400 billion stars. The abbreviation CD often accompanies IC1101, and for good reason. This index in the Abell catalog indicates that the galaxy belongs to a supermassive conglomerate surrounded by a halo of diffuse emission. It was likely due to this feature that IC1101 was initially classified as a nebula. IC1101 was discovered in the summer of 1790 by William Herschel, but was only included in the general classification much later, in 1895, by the Irish astronomer John Louis Emil Dreyer. How did such a vast cluster arise? For an explanation, let's turn to the future of the Milky Way, in whose arm our solar system is located. Its future is 90% predetermined. In 4.5 billion years, it will most likely merge with its larger neighbor, Andromeda. The result will be a large cluster called Milkomeda, which will also include the Magellanic Clouds. Why do we need this information? The ancient, shrouded history of IC1101 was probably similar to the described scenario, and the more scientists study this daunting galaxy, the more convinced they become of this. The last detailed observation of IC1101 was conducted in the 1990s using the relatively primitive telescope at the Kitt Peak Observatory. We now know that the diameter of galaxies with the CD index significantly exceeds the size of their brightest part, which sends the lion's share of the emitted light into space. Interestingly, the cluster's name is supplemented by the abbreviation BCJ, hinting at the dazzling brightness of IC1101. The galaxy is known as the most prominent in its supercluster, called Abell 2029. What's going on inside the largest galaxy in the universe? It is believed that it is populated by old main sequence stars, red and white dwarfs. But at the center of IC1101 lies something monstrous. Scientists are not mistaken in paying close attention to this huge galaxy because not only the galaxy itself, but its components can claim the title of the most. Let us recall a known astronomical fact. At the center of almost every galaxy there is a dormant or active black hole, and sometimes more than one. The Milky Way also has its own radio source, Sagittarius A, with a mass exceeding 4 billion suns. Compared to other galaxies, this is quite small. Guess where the most monstrous black hole in the universe is hidden? That's right, in the center of the IC1101 Galaxy. Astrophysicists suspect that at the time of its birth, that is, the merger of many clusters into one. A similar situation occurred with the black holes located in the depths of the clusters. They merged, forming something infernal and supermassive. If astronomers are right, the black hole at the center of IC1101 may surpass the recognized champion, the black hole inside the quasar TON 618, located 10 billion light-years from Earth. It weighs, for a second, over 66 billion suns. Thus, it is assumed that the weight of the black hole at the center of IC1101 could reach 100 billion solar masses. It is very difficult to believe in such volumes. The human brain simply paralyzes when these incredible numbers are voiced. But this strange galaxy has another property, a clear imbalance in the mass-to-luminosity ratio of stars. In simple words, in addition to giants, dwarfs, black holes, and other inhabitants of the huge conglomerate, IC1101 is populated by something else. Astronomers believe it is the most mysterious substance in the universe, dark matter. It is impossible to observe it directly, only indirectly. The existence of dark matter was predicted in the 1930s during the study of one of the galaxies in the Valles Marineris cluster. A mass discrepancy was discovered, meaning that, considering the maximum possible number of stars, the galaxy should rotate much slower than it actually does. It turned out that it contains a significant proportion of an unknown substance that has mass but does not manifest itself in any other way. This invisible something was called dark matter. When this issue began to be closely monitored, it turned out that not everything is in order with the balance of matter in the universe either. A lot of hidden mass was discovered in the macrocosm, which means that dark matter most likely resides in the depths of IC1101. And the last thing currently known about this huge galaxy is that it is slowly dying. No new stars have been born within IC1101 for a long time, so it lives by absorbing its counterparts, a kind of cosmic cannibal. The emitted light of IC1101, glowing with old gold, speaks of the galaxy's gradual decline, while young clusters glow joyfully with bright sparkles. That's all that can be said about the unknown world, the light from which has been traveling to us for more than 1 billion light-years. It is possible that this galaxy no longer exists in nature, and we continue to study the reflection of a long-vanished stellar dwelling. India. An unexpected question on a channel about space, isn't it? But this is only a superficial view. For many, India is a free, vibrant country, the voice of the gentle Indian Ocean, and eternally intoxicating happiness. For those younger, it's Kipling's stories of Mowgli and Rikki Tikki Tavi. Older generations, wiping away a few tears, will recall the soul-stirring songs from the film Zita and Gita. But today, we'll talk about India in a completely different context. It turns out that the land of elephants and sacred cows has become the only country on the planet to send the cheapest interplanetary mission in the history of cosmonautics to Mars. The Indian government invested 125 crore rupees in the development of the apparatus, which is equivalent to $23 million. The entire project cost approximately $74 million and was completed in just 15 months. Checkmate, Europe and America. Mangalyaan is the name of the Indian probe successfully operating in the orbit of the Red Planet since September 24, 2014. Mangalyaan obviously means Mars craft, and the Indians decided not to bother with a more complicated name. The Mars Orbiter mission, its international name, set another record. It became one of the few spacecraft to enter Mars orbit on the first attempt. Before this, only the European Space Agency had achieved such a feat. The Red Planet is notoriously tricky. Almost all probes on its surface or orbiting it as artificial satellites have experienced setbacks, but not Mangalyaan. It is still collecting information about the planet and has sent many stunning images back to Earth. First, about Mangalyaan itself. It weighs 1,337 kilograms, including payload and fuel. More than 850 kilograms of this mass is fuel. while the weight of the instruments is negligible, only about 15 kilograms. The craft is equipped with a liquid engine, solar panels, and a number of gadgets necessary for achieving the mission's goals. Some of these include MSM, a spectrometer for determining the concentration of methane in the Martian atmosphere, LAB, a 2-kilogram photometer designed to assess the loss of hydrogen from the red planet's atmosphere, MAN, a relatively large instrument studying the most rarefied part of the Martian atmosphere, the exosphere, CS, an infrared thermal imager that helps to map Mars and its interior, and MCC, a color optical camera equipped with many filters, thanks to which Earth receives such detailed and clear images. Considering Mangalyon's payload, we can determine its goals. Orbiting the red planet, the craft primarily studied Mars' atmospheric layers and its mineralogical composition. Mangalyaan also examined details of the Martian surface in detail, and the Indian probe accomplished all these tasks excellently. It's worth noting that the presence of an advanced onboard computer turned Mangalyaan into an autonomous interplanetary station capable of solving most problems independently. So what did the probe see on Mars? It managed to see much that even NASA's publicized equipment couldn't capture. Let's start in order. The image shows the Gale Crater, a 40-kilometer wide funnel located in the Ophir Chasma. On Mars, this name doesn't denote luxury. It's just a desert, rocky part of a huge scar on the planet's body, Valles Marineris. Ophir Chasma, part of a giant network of craters and canyons, was photographed by Mangalyaan from a distance of 1,857 kilometers. The photo clearly shows how steep and abrupt its walls are. The object's depth is about 10 kilometers, and its length is over 300 kilometers. Valles Marineris itself was also immortalized in Mangalyaan's images. This complex system of labyrinths and craters stretches for 4,500 kilometers, a quarter of Mars' circumference. The Titanic Canyon's width is 600 kilometers, and its depth reaches 11 kilometers. Essentially, it's a terrestrial Mariana Trench. This image shows a 3D projection of Valles Marineris. The craft also managed to observe impressive Martian craters, such as a huge impact crater near Huygens and 467-kilometer-old ancient craters that appeared here in time immemorial. Mangalyon's camera also captured Gale Crater and Coprates Chasma. A portrait of our dusty neighbor would be incomplete if the probe hadn't sent an image of the highest mountain in the solar system, the grandiose Olympus Mons. It's difficult to see the details and imagine the true scale of the mountain in this photo, but note that the neighboring rocks seem like pale imitations of hills in comparison. In the 3D photograph, Olympus Mons' power is felt much more strongly. This Martian mountain, a long-extinct volcano, is 26 kilometers high from its base. Compared to the largest terrestrial peaks, it's daunting. Its diameter is 540 kilometers. Not every part of the Earth can boast such dimensions. Its caldera alone reaches 85 kilometers. There is practically no atmosphere at the top of Olympus Mons. A technical vacuum reigns there, with a pressure of only 2% of the surface pressure. For comparison, on Everest, this figure is close to 25%. But let's turn to objects that seem smaller against the backdrop of Mars' size. Mangalyaan managed to capture the unique moment of the tiny Phobos passing in front of the giant Mars. A worthy backdrop for a tiny bug. Here's another remarkable image, the shield volcano Arsia Mons. This mountain, located southwest of Olympus Mons, has a diameter of 435 kilometers and a height slightly less than the Mountain of the Gods, 19 kilometers. Arsia Mons' caldera is even more extensive, with a width of 110 kilometers. It is believed that the mountain is riddled with grottos that appeared after massive collapses. By the way, here is Arsia Mons, next to clouds of water vapor. Did Mangalyaan only take pictures of details of the planet and never a full shot? Of course, there are also full portraits of Mars. This clearly shows the celestial body's ice cap, nestled on one of the poles. In this photo, you can see the planet's atmosphere. But everything comes to an end. We are leaving the Indian mission, having clearly proven that not only Europe and the USA have gunpowder in their powder flasks. If any of you had the thought that this probe is unnecessary for a poor country drowning in garbage, here are the words of one Indian official. We hear arguments that a poor country does not need a space program and cannot afford it. But if we had not dared to dream of greatness, we would still be a nation chopping wood and drawing water. India today is too great to remain on the sidelines of high technology. Do you feel creative abilities within yourself? If so, that's great, because now you'll have to strain your imagination. Imagine you are sitting in your favorite armchair, about to turn on your long-awaited series or a Hubble video. But suddenly you feel a strange vibration and a deafening, gradually increasing hum. Is it an earthquake and a tsunami? Did your neighbor decide to do some gymnastics? Neither. A huge object is falling to Earth right at this moment, destined to end human civilization, destroying everything dear to us in an instant. Don't rush to be horrified or skeptically shrug your shoulders. This is only one of the possible scenarios awaiting Earth. Like other planets, Earth is not immune to global force majeure events. We can go even further and imagine what would happen if, due to some event, all the members of the solar system left their established orbits and found themselves in dangerous proximity to each other. How do you like this situation, and what can be expected from it? First, let's recall the history of the Earth-Moon tandem. Where did the second participant in this duet come from? After all, it didn't accompany our planet from the moment of its origin. There are many theories, but one is most likely: an ancient catastrophe that gave rise to a new celestial body. The hypothesis of the capture of the Moon by Earth's gravity, or the parallel formation of two objects from one protoplanetary cloud, alas, does not stand up to criticism. Based on the fact that the Earth and the Moon are made of the same material, scientists have constructed the following scenario. At a certain point in history, an object comparable in size to Mars collided with a lonely, defenseless Earth. Astronomers even gave it a name, Theia. As a result of this mega-impact event, the Moon formed from the debris remaining in Earth's orbit, a celestial body without which people cannot imagine the night sky. True, some physicists claim that the object that collided with the newborn Earth was much larger than the Earth itself, but that's not important now. What's alarming is something else. It's been a long time since we've seen such collisions. Maybe it's time to be wary? Analogous to pandemics, seemingly appearing on schedule every century. There is an opinion that Theia was located at one of the Lagrange points of the Earth-Sun system, but later, due to a transition to an erratic orbit, it went off course and collided with the barely formed Earth. What prevents the planets of the solar system from being in dangerous proximity to each other, provoked by some event or gravitational perturbation that pushed them off their usual paths? Impact events, in other words, collisions of massive objects with each other, bring a lot of trouble and destructive changes. As a result of a fall and explosion, fires erupt, multi-kilometer tsunamis rise, and earthquakes of unprecedented force occur, exceeding the familiar 9-point magnitude. An asteroid up to 30 kilometers in diameter suddenly falling on Earth can cause such consequences. But a collision of planets equal in size and mass threatens not only the destruction of life, but also the destruction of the celestial bodies themselves. What about a massive cosmic accident? Of course, such a scenario is extremely improbable. We are more likely to be threatened by a rogue planet, an exile from a distant star system. Researchers at Leiden University in the Netherlands casually calculated that a huge percentage of planets belong to drifting, homeless vagabonds in the Milky Way. This figure can reach 100 billion, so the risk is quite high. It's more significant than a collision of Earth with Mars, Jupiter, Mercury, and other previously peaceful neighbors. Meanwhile, two objects can quite coexist in one orbit for billions of years without colliding. Saturn's moons Janus and Epimetheus are a striking example. Their dance continues for eternity. The bodies alternately exchange orbits without causing each other any harm. Amazingly, the distance between the established paths of these objects is only 50 kilometers, a funny distance by cosmic standards. But such a neighborhood is more the exception than the rule. It is too dangerous. It is said that in the distant system KOI 732, 4 planets revolve around the same orbit. Remember the rumors about Earth when an object called Phaeton was attributed to it as a companion? It is assumed that the celestial bodies of this star system are in relative stability because they occupy 2 safe libration points, denoted by the indices L4 and L5, which exclude the possibility of a collision, or rather, postpone it indefinitely. And yet, If we assume that the solar system suddenly transforms from ordered to chaotic and the planets begin to collide, what can we expect from this event? We can say nothing good in advance. Of course, at first, the planets will try to fit into the spacious Earth's orbit, 940 million kilometers long, but soon the neighbors will get tired of crowding together and cosmic scandals will begin. Each will want to conquer its personal orbit, and the Earth will move significantly closer to the Sun, making the conditions on it unbearable for life. The miserable remnants of humanity will hide in air-conditioned catacombs and bunkers. There will be a severe shortage of water and other joys of inhabiting a planet methodically scorched by its own star. However, water can be borrowed from gradually thawing ice giants, though it's unlikely to be drinkable. Many familiar parameters will change: the number of days in a year, gravitational indicators, and the sky's appearance. Unbelievable chaos will ensue, with no chance of restoring the previous order. But this is not the only possible scenario. In another variant, the Earth will be thrown far beyond its usual orbit and will turn into a lonely wanderer, as we described earlier. In this case, things are even worse. All living things on the planet will inevitably freeze, and once beautiful Earth will turn into a dead ice ball. If the planet is knocked out of its saddle, it will rush directly into the fiery solar furnace. Everything will happen in reverse. It will melt in its deadly womb. We don't know how you feel, but we weren't too happy with such gloomy prospects. Moreover, astronomers recently conducted months of calculations using the Cray XC30 supercomputer and, by projecting the history of the solar system 5 billion years into the future, found that instability will sooner or later befall this well-established mechanism. It will all begin with Mercury, which will be the first to fall either on Venus or on the Sun. The modeling process seemed so complex that on an ordinary PC, the calculations would have to be carried out for 2 centuries. It seems that astrophysicists are not mistaken in organizing exercises, developing various Armageddon scenarios. After all, in addition to hypothetical orbital instability, 74 external objects are currently listed on the list of celestial bodies threatening Earth. Let's hope astronomers are simply hedging their bets, but an unpleasant aftertaste remains. What came first, the chicken or the egg? This age-old question can be applied to many spheres of human life, as well as to illustrate controversial phenomena in the universe. Our global home, the origin of which has long been the subject of fierce scientific debate. According to the official theory, it appeared from the notorious Singularity point and has existed for about 14 billion years. But in recent years, scientists have been much less confident than before. When it comes to the age of the universe, evidence that our world is much older has been found too often. For example, the cosmic elder, the star Methuselah, turned out to be 1 billion years older than the universe itself, which is impossible in principle. It is not surprising that astronomers cannot explain this discrepancy. The singularity concept is also not entirely smooth. Orthodox theory states that everything began with it. But is this so? First, let's answer the question. What is a singularity, and is it possible to imagine it, even remotely? The word comes from the Latin singularis, meaning unique. This concept is successfully applied in mathematics, philosophy, and other scientific fields. In particular, there is the expression technological singularity, meaning a hypothetical state of progress moving so rapidly that it gradually escapes our understanding. But today, we are interested in the cosmological singularity as the starting point of the universe's birth. Let's state right away that this is such a strange, incomprehensible phenomenon that attempts to explain its essence in simple words seem rather pathetic. Briefly, it is a point in which all physical parameters, temperature, density, energy, tend to infinity. Familiar laws do not work there. Accordingly, their comprehension and forecasting lose all meaning. It is from this point, according to the Big Bang Theory, that everything we see now originated, including the Milky Way, the solar system, and humanity as a whole. Today, we will try to lift the veil of time, or rather, rewind it back and find out what was before the Big Bang. A decade ago, such a question was considered the height of ignorance, since adherents of the singularity did not even allow the thought that everything existing appeared in some other way. Voicing such a suggestion would have been tantamount to admitting that 2 + 2 does not equal 4. Now, however, some scientists dare to speak about the absurdity of the very concept of singularity, although Stephen Hawking proved the possibility of its occurrence back in 1967. So, to use the words of a classic, was there a boy? Think about it. Practically everything that surrounds us has a past. Humans, animals, long-dead civilizations, planet Earth, the sun and other stars, huge galaxies and nebulae. But is there a yesterday for our universe? Did something exist before the Big Bang? And what role did singularity play in this past? The vast majority of astronomers believe that before the Big Bang, there was nothing, absolutely nothing. Everyday experience shows us the absurdity of this assumption, since it's impossible to make even a stool out of nothing. Nevertheless, astronomers claim that in this void, not only particles did not exist, but space and time themselves were absent. This is practically impossible to imagine. Therefore, scientists have undertaken experiments. Special boxes were built, the temperature of which was lowered to almost absolute zero, the insurmountable boundary that we talked about in one of our previous episodes, and the number of particles was minimized. In this way, astrophysicists tried to recreate this very something that gave rise to the Big Bang. It turned out that in the seeming void, some processes can still occur, capable of provoking such an extraordinary phenomenon as a singularity. But still, most scientists do not believe in the origin of the universe from nothing, considering the Big Bang a prominent cataclysm but not attributing to it the function of the creator of all things. Some astronomers expressed the opinion that the collision of two conglomerates provoked the explosion and gave rise to a single superformation. A simple example: the future merger of Andromeda and the Milky Way, with the formation of the end product, the huge Milkomeda. But the hypothesis of the progenitor of our universe, which existed before the emergence of the singularity and the Big Bang, is particularly actively promoted. Cosmologists from the UK advocate for it, believing that the Big Bang was not the beginning. Time simply changed its orientation at the moment of detonation. Space also underwent changes, as David Sloan of Oxford University put it, not physics, but the map of the world broke down. You can't say it better. What could this strange world, the ancestor of our universe, have looked like? And what gave rise to the clot of infinite density and energy, the mysterious and inexplicable singularity? The scientist's bewilderment is not surprising, because our ideas and predictions are based on physical laws and postulates. But in the case of extremely high energies, they cease to work. Various hypotheses have been put forward, and the late Stephen Hawking completely dismissed such discussions as meaningless, preferring to believe in the complete absence of anything before the Big Bang. Experts from Oxford have achieved some certainty in this matter, creating a computer model of the universe before and after the explosion. They took a non-trivial path, assuming the following: if we, being inside our own macrocosm, are unable to accurately measure its parameters and compare them to anything, it means that the Big Bang and other physical postulates are relative. This assumption was incorporated into the program. A model of a dimensionless universe was placed in it. The modeling results stunned everyone. The chronological algorithm showed that the Big Bang is only one of the coordinates on an infinite straight line, and it was not generated by singularity but by another structure, which astronomers conditionally called Janus. Why did they use the two-faced god? It's simple. Matter in the formula was replaced by antimatter, a mirror copy of existing particles. The result was a mirror universe, similar to the one once invented by Lewis Carroll, where time flows backward and complete inversion reigns. It turns out that the appearance of antiprotons, antihelium, and antineutrinos in our world is a banal leak. Singularity is nothing more than a myth, a projection of the expansion of the universe demonstrated to us for decades, an ordinary fiction. Checkmate. Orthodoxy. What this grotesque mirror world looks like is extremely difficult to imagine, but if someone inhabits it, its inhabitants are unlikely to feel any discomfort. For them, time would flow normally, because comparing this indicator is elementary for them. Let's immediately disappoint you. We will not be able to communicate, because we are each other's past. Of course, this is not the only hypothesis for the appearance of the universe. Some astrophysicists adhere to the theory that our world was born from the depths of a monstrous black hole, where matter collapsed and then suddenly expanded, provoking the Big Bang. Moreover, the expansion of our universe will launch the infinite appearance of new worlds, and this process will not stop. It is noteworthy that astronomers noticed the prerequisites for the emergence of new universes in the cosmic microwave background. They currently look like light anomalies, precursors of subsequent Big Bangs. Whichever theory is true, one thing is clear. As Socrates once said, we know that we know nothing. But nothing prevents us from fantasizing. If you have your own versions of what was before the Big Bang and whether the singularity existed, share them in the comments. What is the true nature of the universe? To answer this question, humanity has invented many theories. The world needs to be fitted into narrow frameworks, an integral part of human cognition of the surrounding world, simplification, fitting to existing scientific theories, or, if the old theories no longer suit us, the creation of something completely new. The more we learn about the universe, its structure, and its laws, the more sophisticated our scientific theories become, designed to explain it. String theory, a controversial theory often misunderstood, is an example, a theory about the nature of everything that surrounds us. But does this theory really explain everything? Maybe it's just one of many similar ideas, and soon it will be replaced by something more successful. What does a person do to understand reality correctly? They try to observe and analyze this reality. Scientists use complex optical instruments to see extraterrestrial landscapes and creatures inhabiting the very tip of an ordinary sewing needle. You can, without any tools, simply approach and observe the behavior of birds on a sunny spring day. Not everything we see consists of molecules, which in turn consist of even smaller particles, atoms. For a long time, we thought that atoms were the last layer of reality, until our scientists decided to collide two such particles. They discovered that there are things that cannot be divided to infinity, elementary particles. There is a problem, however. These elementary particles are so small that we simply cannot see them. Let's remind ourselves what vision is. To see something, we need light. Scientists consider light as a set of electromagnetic waves. Such a wave is reflected from the surface of an object, and it is this reflection that is recorded by our sensory organs, the eyes. The wave carries information about the object, which, in turn, is interpreted by the most perfect of all computers, our brain. It creates an image of this object, drawing on all the experience of its past analyses of reality. The object is given a light format and many other properties. Thus, you are not simply observing an object but interacting with it in a certain way. With most objects, the observation process is not associated with any difficulties. We can easily see a dog or an elephant. A person with poor eyesight will put on glasses or use lenses to read an inscription on a shop window. Scientists will use a microscope to see the cytoplasm of an amoeba. But what about the smallest particles that are simply impossible to see, even with the finest and most complex instruments? Imagine these particles are so small that electromagnetic waves of light do not interact with them at all. They simply bypass them. We can try to change the properties of electromagnetic waves and make them shorter or longer. However, by doing so, we give such a wave a greater energy charge. When we interact with a particle with a highly charged electromagnetic wave, it repels them. Incredibly, even simply looking at a particle, we change its properties, or, speaking more scientifically, we cannot simultaneously accurately measure its properties. In science, this is called the Heisenberg uncertainty principle, and this principle, in turn, is the basis of all quantum physics. What a particle looks like and the nature of its existence are still unknown. Even with the most accurate instruments, we can only see its sphere of influence, but not the particle itself. However, we know that they exist. But how can we then use this knowledge for scientific purposes? This is where humanity's experience in building numerous theories that have arisen throughout the history of science comes in handy. The idea arose of the existence of material particles, or, as it is otherwise called, a material point. Scientists agreed that a particle is a certain point in space. Each electron is a point with a specific electric charge and mass, and they are inextricably linked. Thus, quantum field theory arose, solving a huge number of theoretical problems that face scientists. All conventional models in particle physics are based on this theory. Thanks to it, Some quantum properties of an electron have been brought to a value of 0.00000000002%, which, you must agree, shows fairly high accuracy of calculations. Naturally, it should be understood that in reality, a particle is not a point in space. But hypothetically taking it as a point, we get a well-working and logical picture of the universe. The most amazing thing is that this works not only in theory but also in real products of progress that we use every day. The existence of a maglev train is largely due to quantum field theory. There is a problem: gravity. In quantum mechanics, all physical forces are tied to certain types of particles. But according to Einstein's general theory of relativity, gravity is unlike other forces in the universe. Gravity is directly related to the geometry of space and time. And it is precisely in quantum space that geometry begins to have very large inaccuracies. It turns out that gravity does not work in quantum physics. If we manage to harmoniously combine the concept of gravity with the standard model of quantum physics, we will get a theory of everything, the most complete model in the history of humankind of the functioning of the universe. So scientists needed to sit down for calculations again. The question arose: what could be more complex than a point, a straight line, or otherwise a string? Thus, string theory was born. This theory describes various elementary particles as different vibrations of a string with all possible rigor. Remember how different strengths of string vibrations on a guitar lead to the emergence of completely different musical sounds. Approximately the same thing will be observed in the world of elementary particles. By the way, gravity fits perfectly into this model. Thus, string theory claims to unify all the fundamental forces in the universe. A discovery of the century. Finally, humanity has discovered a theory of everything. But there is always a fly in the ointment. Most of the mathematical calculations that make up string theory simply do not work in our universe with 3 spatial and 1 temporal dimension. This theory needs no more and no less than 10 dimensions. There have been many attempts to simplify it to the standard 4 dimensions, but so far they have all been unsuccessful. At present, there is no experimental evidence of string theory's operation. Someone will ask, what is the use of this theory then? Imagine that humanity had never come to knowledge in aerodynamics. The airplane would never have been invented. We have no idea about overcoming the sound barrier. Would we have been able to build and launch the first spacecraft beyond Earth without this knowledge? Science develops gradually, step by step, stage by stage. String theory may be just one variable for solving the universal equation. We can abandon this theory without trying to refine and improve it, or we can try to go this path to the end, and who knows, maybe at the end of this difficult road, we will find an understanding of the mechanism of the universe. Humanity strives to study the cosmic expanses as best as possible, sending spacecraft to the darkest, unknown corners of the universe. Meanwhile, there are many unstudied territories on planet Earth. It would be nice to pay attention to the world that neighbors ours, but is studied even less than the vast macrocosm. The world ocean is an environment where fish, crabs, seahorses, dolphins, whales, and more exotic creatures feel comfortable, but not humans. We cannot breathe underwater for a long time without special devices, and the pressure, which increases with depth, can kill us even when diving just a few tens of meters. Nevertheless, despite all our physical unsuitability and imperfection, people have managed to penetrate the most secret places of the world ocean, in particular, the mysterious location where Mount Everest, the highest mountain on the planet, could be easily submerged, and there would still be plenty of room at the bottom. Try throwing the tallest building on Earth, the Burj Khalifa, there as well. You will laugh. But even then you won't be able to fill the insatiable funnel to the end. What kind of amazing space is this, practically inaccessible to the human eye? You probably guessed that we are talking about the Mariana Trench, the deepest depression located in the Pacific Ocean at a depth of about 11 kilometers. On the surface of the Earth, this distance can be covered in 3 hours, but not in the ocean. For a long time, the Mariana Trench was considered absolutely lifeless and deserted, but in the middle of the 20th century, this myth was dispelled. People learned about this titanic trench, where not a single ray of sunlight penetrates, relatively recently, at the end of the 19th century, or rather, in 1875. But then, as now, there is confusion with the parameters of the trench, especially its most remote parts, Challenger Deep, as it is extremely difficult to measure such a gigantic depth. Initially, it was stated that the Mariana Trench did not exceed 8,367 meters. After repeated measurements, the figure changed to 8,184 meters. This data came from the HMS Challenger, but much later, in 1951, researchers announced the number 10,863 meters. The Mariana Trench was measured repeatedly. The depth constantly changed. In 1957, 11,022 meters. In 1995, 10,920 meters. In 2009, 10,971 meters. And in 2011, 10,994 meters. Why do the numbers differ? It's simple. Measurements of such an impressive funnel encounter a number of problems. For example, the speed of sound at different depths differs, which affects the readings of the echo sounder. But it's much more interesting to find out what or who is in the abyss, as well as who and when managed to descend to the bottom of this hellish funnel. For the first time, this happened in 1960 using the Bathyscaphe Trieste. On board were American Lieutenant Don Walsh and